Hi, my name is Angel Bringas, and today I'm going to expose my final oral examination that was taught by teacher Eric and about the block of modeling movement in engineering with conservation laws. Well, the question about which I'm going to talk about today is the things that I need to add or modify to our original program that we created on classes in order to calculate an integral with the midpoint rule. Well, what I'm gonna do on this exam is to add all the parts that are necessary in order to a part of calculating the area between, below that function, the integral of that function. Now I'm also gonna plot a graph that describes, like the movement that it takes. Well, first of all, I have here my original code that we realized during this semester, talking about the midpoint rule. And it's this one, and as you can see, the only output that we receive when we conclude our program is this, now that it tells us the value of the integral that you gave us is, and it gives us a value. In this example, I'm evaluating the trigonometric function of sine of x in the limits from 0 to 2. Well, here are the parts that I added to my original program in order for it to also plot our graph. First of all, we created one variable called xVals that, what it's gonna do is to put the 100 points on the x-axis from the point A to B, that is from point 0 to 2, and it's gonna give us a specific point between 100 rectangles on that, those two limits from 0 to 2. The y value, the y vals, a variable that we created, it's gonna evaluate each one of the points from x that we obtained before in our function that here it is also sine of x, as you can see as in this comment. What it is gonna do is to put each value with the ones that we created from 100 rectangles from the previous point, and it's gonna evaluate it on the function in order for us to get the value on y. And finally, I put here also a comment that it's called plotted, that it refers to the graph that the program is gonna plot. With this, this part it's called figure, it tells us, it opens a new window of figure in which the program is gonna plot the function that we asked him to do it. And here obviously we need to put the 2 points in which we are gonna evaluate, that are gonna be the two variables that we created, one for x and also the other one for y, that as we called them before, are xVals and yVals. This is how it looks our program. Our program, more or less, as I explained you, it's going from 0 to 2, and we are evaluating the function of sine of x, a part that it's also giving us the part that we did before during the whole semester of calculating the area of the integral. Now I'm gonna show you more or less how does it works. So let me take the mobile phone and I'm gonna open MATLAB. Give me 1 second. Yes, here we have it. So this is exactly like what I just showed you. If we press here run, now we are gonna change it a little bit. We're gonna calculate it from 0 to 4. So first of all, it tells us which is our lower limit. I'm still gonna consider number 0. Then it tells us which is gonna be our upper limit. And as I have told you, we're gonna consider now number 4 instead of number 2 in order for it in order for us to see how does the graph is plot. We also gonna consider 100 rectangles in order not to modify that. And it tells us that the approx value of our integral is of 1.65, and this is how it looks like, more or less. We go from 0 to 4 in the x-axis, and obviously the x-axis is here in 0, so as this area is below, it's also plotted. Thanks for your attention, hope you enjoyed and hope you understood this topic.